Good morning again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually we're going to go on and cover section 8.4. But first of all, are there any questions from last night's homework, section 8.3? Brief pause. He waits. Any questions? All right. In that case, I'm going to take a little bit of time and I'm going to look at some questions that somebody emailed me from 2 nights ago. Ordinarily, I wouldn't do that, but since we've got a little time, I'm going to go ahead and look at that. Okay, because I think it might be a good review for all of us anyway. So the first problem said graph f of x equals 2/3 x minus 2. All right, so using slope-intercept form, the slope of this line is 2/3 and the y-intercept is -2. Okay, so using that information, a slope of 2/3, let me write that down here. A slope of 2/3 and a y-intercept of -2. Okay, let's see if I can pull this off. I'm going to close that and open this. And if we make a graph like so, and then we plot the point. Let's see here. We plot the point -2 or 0, -2, the y-intercept, and then we're going to go up 2 and over 3, up 2 and over 3, up 2 and over 3. And from there we can go up 2 and over 3. And I can't see the whole thing, but anyway. Yeah. Oops. It's messing with me again. Okay, anyway. It doesn't want to, I know why it's doing that. Okay. Anyway, that's what the line would look like. Any questions on that? Okay. Actually, I'm going to stay here and I'm going to undo all of this. And we're going to look at a second problem that said graph, let's see, I think it was like f of x equals 2. Well, that's like y equals 2, which is a horizontal line passing through 2. So it would look just like that. Okay. I'm going to go back to the other screen. And let's see here. Okay. Can you see where it says f of x equals 7?
Yes.
Okay. So actually, I said 2, it would have been 7. So that graph would have gone up 7 units, 4, 5, 6, 7, and drawn a horizontal line at y equals 7. Anyway, if you have any more questions about those, please email me, because like I said, that's a couple days back, but I'm going to go ahead and look at just a few more here. This says we're supposed to come up with a linear function that has a slope of 1/2 and passes through the point 4, 1. So if we use y equals mx plus b, the slope is going to be 1/2. We're going to put 4 in for x and 1 in for y. 1 equals 1/2 times 4 plus b. Simplifying, 1/2 times 4 is 2. Isolating b, we get b is -1. So y equals 1/2 x minus 1, or f of x equals 1/2 x minus 1. So that's how you would do that problem. Any questions there? All right, here's another one. come up with a linear function that passes through the following 2 points. Well, I want to get it in a form y equals mx plus b, so I need m and b. M is the slope. I don't have that, but I could use the slope formula. And the 2 points, this will be point 1 and point 2. So y sub 2 is -6, y sub 1 is 4, x sub 2 is 2, x sub 1 is -2. -6 minus 4 is -10. 2 minus -4 is 4. This reduces down to -5/2. So the slope is -5/2. Well, now I can take the slope, put it in there. Again, take an ordered pair, in this case, either ordered pair. I'll use the first one. X is -2, y is 4. 4 equals -5/2 times -2 plus b. Simplifying that, we get what? 5 plus b, 10 over 2. Subtract 5 from both sides, -1 equals b. So y equals -5/2 x minus 1, or f of x equals -5/2 x minus 1. Any questions about that one? All right. Finally, the equation of a horizontal line that passes through the point 6, -47. Well, a horizontal line is in the form of y equals a constant. Since this point has a y value of -47, the y value would have to be -47. So f of x equals -47. Anyway, the person that asked for those, if you still have questions, email me. I'd be happy to go through more details with you. With that, we're going to go on to section 8.4. All righty. So let's see here. We're going to talk about the idea of union and intersection, and we'll get there eventually. Actually, you know what? Let's talk about that first. Let's say that this is Nob Hill Boulevard, and this is 16th Avenue, okay? What is that? Anybody?
The intersection.
Right, the intersection. Okay. So let me ask you this. This piece of property, the intersection, is it part of 16th Avenue?
Yes.
Is it part of Nob Hill Boulevard?
Yes.
Yes.
Yeah. So the intersection is the part that the two streets have in common, right? Or where they overlap? Okay. All right. So that's the idea of a intersection. Now, what if I, and who is now my wife, but at the time was my future wife, I've got all this stuff, and my future wife has all of this stuff, and we get married, we form a union of all our stuff. So intersection is where the two overlap, what they have in common. Union is everything from both groups put together. Okay? You all right with that idea?
Yes.
Okay, let's take that a little further. Let's see. Grand Funk. Guess who? Randy Stonehill. Barry.
These are some really old groups.
What are you saying, buddy? These,
Hey,
I inherited these from my great grandparents. See.
Okay, okay.
Grand Funk Railroad. It's the
What's
best.
that?
Grand Funk Railroad's the best.
All right. Oh, well, okay. In that case, we'll even put their. Let's see. Let's see what do we got here. Star Wars. And now, before we got married, I had in my record collection, and again, you know, parts of this are true, but parts of it are made up to make the story fit. But I owned these 3 records. That's true, but I owned a few more as well. And my wife-to-be owned these 3 records. Okay. So when we got married, we had a yard sale. What did we sell at the yard sale?
Barry Manilow.
Well, I would have liked to, but no.
Oh. The Guess Who?
Right. Why?
Because you both have a copy.
Right. So that's what we had in common. That would have been the intersection between our 2 record collections, would have been the Guess Who. Okay. Now, what's in the union of our record collection? Grand Funk Railroad, the Guess Who, Randy Stonehill, Barry Manilow, Star Wars. I don't need to mention the Guess Who twice in the union. Okay. So the union is all of it together. The intersection is what it has in common. Okay. Let's take that into a more mathematical scenario. Let's say we have a set, we're going to call it set A, and it has the following members or elements or numbers. Let's see. Okay. And then we've got set B that has 4, 6, 8, and 10. We've got set C that has a very bad looking attempt at a brace. -3, -1, 0, 1, 2. And finally set D that has elements -3, 1, 2, 5, and 8. Okay, let's see if I can clean this up a little bit there and there. And that's supposed to look like that. And there's a comma. Okay, so I've got those 4 sets. Each one of those sets contains the numbers or elements that are between the set of braces. Okay? Now, the idea of a union, where you take everything, the symbol for union, this is going to be pretty tough, it's a U. Okay, so that symbol means union. The symbol for intersection is an upside down U. So this means union, that means intersection. Okay, now let's say I want that. That means I want the intersection of set A and set B. So what would be in the intersection of set A and B? Don't all jump in at once now.
4 and 6.
Correct. Good job. Okay, so looking at set A and set B, that's what they have in common. So the intersection of A and B is 4 and 6. Okay. How about the intersection of B and C? It's like that date you went on last night, right? You and your date had nothing in common. Bummer. That's what you get for doing that internet dating. Okay. B and C have nothing in common, right? You see that?
Yes.
All right. Now, there are several different ways we can say that. One of them is to use this symbol. Another one is to use this. This is to represent the empty set, or the null set as it's called. This is also representing an empty set. It's a set, but there's nothing in it. Now, what you don't want to do is this. You don't want to have an empty set, but oh, you put the symbol for empty set inside the empty set because now it's no longer empty. Okay? So either this or that says They have nothing in common. I tend to use this because it's easier to make a circle with a line through it than it is to make these squiggly things. All right, we okay with that? I'll take that as a yes. Okay, so now I'm going to go back and look at some more problems. Okay. How about this? So that means we want the union of A and C. So we want everything that's in A along with everything that's in C. And I'm going to put them in increasing order. So I'm going to get -3, -1, 0, 1, 2, 3, 4, 5, and 6. Notice I don't list the ones that are duplicates twice. I just list them once. Okay?
I had a question about this one.
Yeah.
Unless they say otherwise, are you usually supposed to put them in increasing order, or does it not matter?
Let's just say do it. Okay.
Okay.
I didn't really answer whether it matters or not, but it's kind of like when you're drinking tea with the queen, do you put your pinky out thusly or not? You know, will they
Okay.
throw you out of the palace? I don't know. So let's just say do it. Okay.
Okay.
All right. Okay. So union, intersection. Union, intersection. All right. Now, there are also words that are used to mean the same thing. For union, we use the word or. For intersection, we use the word and. The way that I remember that is that if you look at the word and, the intersection symbol's right there in the middle, isn't it? Well, almost. Okay, now, what we're going to do, we're going to look at two different inequality statements. X is greater than -2, and X is less than or equal to 5. This is what's known as a compound inequality. We have two separate inequalities, but we're going to do this to them, which means we're going to find the intersection. So where they overlap, what they have in common. The instructions, they want us to solve it, graph it, and write the answer in interval notation. So the first thing we're going to do is solve it. Now, I'm going to actually graph the individual pieces. You don't have to do this, but I think it's a good idea to get you to the final answer. So X greater than -2 on a number line. X greater than -2. And this is another case of where if you have forgotten all this and need to brush up on it, this is back in chapter 2.7. And if you really need a lot of brush up, come to my office hour. Be happy to go through to more extensive review of it. But X greater than -2, we're going to put parentheses at -2 with an arrow going to the right because it says it's greater than -2. Okay, now X less than or equal to 5. Less than or equal to 5, we're going to put a bracket because it includes the equals to and an arrow going to the left. So those are the two individual pieces. But we want the intersection. What do they have in common? Well, now keep in mind this arrow continues on, right? So it seems to me that we've got everything right all the way over to here. So what would that look like? Well, we would have a parenthesis at -2 and a bracket at 5. Now, why wouldn't there be a bracket at -2? Because they don't both have -2. The bottom one does, but the top one starts right after -2. They do both include 5 because this one on top goes on forever to the right and includes 5 on the bottom. So there's the graph of the solution. Okay. Now, how would I write that? I would say x is greater than -2 and less than or equal to, oops, that shouldn't be a -5, that should be a 5. My bad. Okay. And then finally, interval notation. We're not including -2, but we are including 5. So here we have the solution, the graph of the solution, and the interval notation of the solution. They're all saying the same thing. X is greater than -2 and less than or equal to a +5. Do you have any questions about this particular example? As I say again, I didn't have to do this part of the problem, but my experience with students over the years has been that it's better to see what's going on in terms of the intersection if you look at both pieces before you try and visualize the intersection. All right, let's go on to another problem. Let's see here. This says 2x minus 1 is greater than 3, and x plus 8 is less than or equal to 11. We're still looking for an intersection because it has the word and. However, we need to solve each inequality first. Recall, in fact, we looked at this way back. The first thing we did in this class, we graphed linear inequalities. Recall that if you multiply or divide both sides of an inequality by a negative number, you change the direction of the sign. Otherwise, you leave it alone. All right, so here I'm going to add 1 to both sides. 2x greater than 4. Divide by 2, x is greater than 2. The second inequality, I'm going to subtract 8. I get x less than or equal to 3. So now this is what I'm going to deal with. X is greater than 2. X is less than or equal to 3. Okay? So let's look at x greater than 2, what the graph of that looks like. I would have parenthesis with an arrow going to the right. X less than or equal to 3. I would have a bracket and arrow going to the left. Again, we're talking about intersection, so it would go from, well, let's see here, let's do that. Let's do that first. So the graph, I'm going to try and fit this all on the same page. The graph, 1, 2, 3, would go from there to there. So you'd have a parenthesis at 2 and a bracket at 3. You would say x is greater than 2 and less than or equal to 3, and interval notation would look like that. So you've got the solution, the graph, and interval notation. Alrighty, questions there? Let's see here. Let's take a look at this one. 3 halves x plus 1/5 less than 5, and 2x plus 3, excuse me, 2x plus 1 greater than 9. Okay. So to solve the first inequality, do you want to clear the fractions or just live with them? Your choice. You tell me. Nobody cares?
Yeah, no, not really.
Not really?
Can do it either way.
Okay, you know what? I'm going to clear them. I'll clear them. So what's the LCD of 2
It'd be
and 5?
10. It'd be
Okay.
10.
So I'm going to get 2 times 3 halves x plus, excuse me, not 2 times, 10 times 3 halves x plus 10 times 1/5 less than 5 times 10. So that's what, 15x plus 2 less than 50. Subtract 2 from both sides, 15x less than 48. Divide by 15x less than, I could take out a 3 and I'd have 16/5, I believe. Okay. We all right with that? Any questions? Okay, let's take the second one. Subtract 1, 2x greater than 8, divide by 2, x greater than 4. So I'll bring that down here. So that's what I'm going to deal with right there. I'm actually going to take that and recopy it on the next page. So I've got x less than 16/5 and x greater than 4. Okay, I want to find the intersection. So let's see, x less than 16/5. Let's see, 16/5 as a mixed number, that would be what, 3 1/5. So 1, 2, 3. That's going to be, we'll call this point right here. We'll call that 16/5. Okay, so my I'm going to have a bracket with an arrow going this way, and then x greater than 4. 1, 2, 3, 4. So 4 is over here, and it says x is greater than. So I've got parentheses and an arrow going off in that direction. Okay. So intersection, what do they have in common?
Nothing.
Nothing. And we're done in terms of that. So those two have nothing in common. All right. Now we're going to look at what is known as a double inequality. And it says 4 less than or equal to x plus 3 less than or equal to 7. Basically, this is kind of an intersection that's already happened. Okay. But what we need to do is we need to solve this for x in the middle. But there's 3 pieces. There's the left end, the right end, and the middle. Whatever I do in the middle, I have to do to the left and the right end as well. So now I've got 1 less than or equal to x less than or equal to 4. So there's your solution, the graph of that. Let's see, I would have a bracket at 1 and a bracket at 4 and a solid line segment in between. Interval notation would look like, excuse me, that. You okay with that? All right, let's see here. Let me find. Let's do one more here. -2 less than negative b plus 3 less than or greater than that, less than 5. All right. So here again, to solve this inequality, this double inequality, we need to solve for b in the middle. So I'm going to subtract 3 from each of the 3 pieces. And I get that. What do I need to do next to solve for b?
Divide by the minus sign.
So divide by -1.
Yes.
Don't you have to flip around all your signs now?
Yes, you do, which is exactly why I chose this problem. Because I divided everybody by a negative, I flipped both signs around, didn't I? Okay, now, the problem is now this statement is backwards. That is to say, we want to write our final answer from smallest to largest. So consider this, if 5 is bigger than b, and b is bigger than -2, isn't this also true? Now, I'm not flipping the signs here. I'm just changing the whole viewpoint. For instance, Roger, would you think it's fair to say that I'm older than you?
Sure. Yeah.
So I'm older than you, which also means you're younger than me. It's the
Yeah.
same comparison, but from a different viewpoint. Okay. So if we say Ben older than Roger, we could also say Roger younger than Ben. So I'm just taking this and rewriting it from smallest to largest. That's not the same thing that I did up here when I divided by a negative number and just changed the signs. Here I changed the whole thing around. Okay. And you want to do that before you go to graph it or use interval notation, or there's a good chance you'll get them backwards. Trust me, I've seen bright, intelligent looking students just like you in the past do this. So now I've got my solution, my graph. Let's see, I'm going to have 0 and -2 and 5, and it's going to be parentheses, parentheses, 0, and then interval notation is going to look like that. So there's my solutions. All right. So that's dealing with a double inequality. You want to solve for the variable in the middle. And now for the last piece of the puzzle, we've looked at and, which is intersection. Now we're going to look at or. Let's say we've got x less than or equal to -2 or x greater than 6. All right. Now, both of these inequalities have already been isolated for x. Okay. Let's take a look at the graphs. X less than or equal to -2. So let's see, 0, 1, 2, -2. I'm going to have a bracket and arrow going to the left. X greater than 6. Let's see here. 0, 1, 2, 3, 4, 5, 6. And I'm going to have parentheses going there. All right. I want to talk to you about the state of Hawaii. Hawaii is made up of several islands, okay? So the union, the state, includes all of those islands. But geographically, they are separate. So if you look at Hawaii on a map, there's water between the islands, right? You can't go from Oahu to Maui in a car driving. Okay, you can't walk there. You have to either fly or take a boat there or swim and hope you beat the sharks, whatever. Okay, but geographically they're separate, even though the union says they're both a part of the state of Hawaii. Okay, why am I talking about all that? Because that's what we've got going on here. We've got, let's see, if we were to graph the solution, it would look like that. If we were to write the solution in interval notation, it would look like that. Everything from negative infinity up to -2 inclusive, in union with everything after 6, okay? Because we can't write it as a single interval, just like Hawaii, the state, is not a single land mass. And yeah, I know you could say they're all connected underwater, but we're not going to do that, okay? You all right with this?
Makes sense.
All righty. Good. Now that I've got you all thinking about Hawaii, no one's interested in math anymore. Now, let's see. Let's take a look at this one. 2x greater than x plus 3, or x over 8 plus 1 less than 13 over 8. And again, we have a union situation, but again, we need to solve each separate inequality before we unionize them, so to speak. All right, so the first one, I'm going to subtract x from both sides, and I get x that's supposed to be a greater than 3. Okay. Let's see, on the right side, I think I'm going to go ahead and clear the fractions. I'm going to multiply each side by 8. So I get, what, 8 times x over 8 plus 8 times 1 less than 13/8 times 8. So this is x plus 8 less than 13. Subtract 8, x is less than 5. So I've got x greater than 3 or x less than 5. So that's getting ready. Okay, any questions about what I've done so far? Again, I'm going to take that and recopy it on the next page so I have more room to work with. Let's see, it was less than 5. Okay, so I'm going to look at the individual pieces here to see what's going on. Let's see, I'm going to put in 0, 1, 2, 3. So x is greater than 3. And then 1, 2, 3, 4, 5. X is less than 5. But we want the union. So what does the union look like?
It's going to be a parentheses on 3 going to the right to infinity, right? Kind of like the
That's-
top, kind of like x is greater than 3.
So what about this though? Isn't that part of the union?
Oh, that's going the other way now.
Ah,
'Cause it's less than 5.
so
Whoops.
what's the union?
There would be parentheses on the 5 and the 3.
You're
Oh,
thinking intersection. I'm thinking Arby's. What's the union?
Oh, it'd be infinity 5, right? Parentheses, infinity 5 parentheses, right?
You've left those out.
Oh, dang. This is tough.
Would it
Infinity,
just do
infinity?
What? What, Anthony?
It'd be infinity, infinity?
You almost said it right.
Oh, with the
You said
parentheses,
infinity.
And then, yeah, right?
What's down in this direction here? Is that infinity?
Oh, negative infinity, wouldn't it?
Ah,
Oh,
our
man,
graph,
this is hard.
our graph would be just a solid line.
Okay.
X is that, an interval notation. Basically, it's all real numbers. It's that marriage made in heaven. Between the two of them, they had it all. Do you see it?
It's complicated, but yeah, I do.
This has everything above 3. This has everything below 5. So when you put them together, between them, they've got it all. Now, if we change this to and we just wanted the intersection, then it would just be between 3 and 5, but it's or. So you've got to know your vocabulary, okay? A U, union, the word or, union, upside down U, intersection, the word and, intersection. Intersection, what they have in common. Union, all of both. Okay? One more example. This says -6 less than f of x less than or equal to 0, where f of x equals 3x minus 9. I believe that all the authors are trying to do here is just get you used to using function notation. Basically, all we're going to do is make a substitution. We're going to take that and put it right there in place of f of x. So that gives us -6 less than 3x minus 9 less than or equal to 0. And by the way, technically, you read this from the middle. I've been saying -6 is less than 3x minus 9 is less than or equal to 0. From the middle, you would say 3x minus 9 is greater than -6. So it's kind of like I'm reading it backwards. And it's less than or equal to 0. Okay. Let's say there were, let's do this. Let's say there's 3 people. Here's my lovely drawings. And okay. And here is me. I'm 62. I know it's hard to believe that. I mean, I got up this morning. I had to get my walker, you know, and okay. And let's say there's somebody here that's 18 and somebody here that's 40. Okay. And this is Ben, and this will be Brad and Charlie. Okay. So if Brad's describing the situation, Brad would say, I'm younger than Ben and older than Charlie. Right? So you could say Brad is what? Ben is older than Brad and Brad is older than Charlie, but it's all about Brad. So from Brad's viewpoint, Brad is younger than Ben, but older than Charlie. What am I getting at here? So here, that's Brad. Okay. You know, so here you'd say Brad is older than, or you'd say 3x minus 9 is greater than -6 and less than or equal to 0. I don't know if I got you completely confused, if you're trying to figure out what Charlie had to do with anything. So now I'm going to solve this thing for x in the middle. I'm going to add 9 to all 3 pieces. Be careful when you recopy things. It's easy to forget like the equal part below the less than, things like that. What do I need to do next here?
Divide both sides by 3.
All 3, actually, all 3 pieces. So I'm going to get 1 and x and 3. All right. So there's my solution. If I graph that, let's see, it would be like that and like that. And then interval notation like that. It's this thing here. All righty. Well, I think I've tormented you enough for one day. So I'm going to stop the